Okay, let's do network forensics number 2. Um, so this video is a continuation of the first network forensics that we looked at earlier. So in order to understand most cybercrime these days, and the forensics involved in network-based crimes, it really is kind of important that we understand a little bit about networks. This is the more advanced lecture on networks. So the first thing that I want to explain to you guys is that an internet address really has two parts, and that is an address and a host address, or I should say a network address and a host address. So the whole idea of the network address is that it is an identifier of a network. So we could have a network, for example, abc.com, and that particular organization could have a network address that looked like something like this: 198.152 dot 201, and this might be their network address. Here. And then, looks like my finger was writing on the screen. So let's go back here, 201. This is the network address. And then they may have numbers that go anywhere from 001 through to 255. And in this case, this would be the host address. So you might get something that looked like this. And that would represent the entire address of a particular computer. So network addresses come from the numbers authority. Here, the Internet Assigned Numbers Authority. And the device address or the network address comes from whoever administrates the network. Okay, so the important thing here is to remember that the addresses have two parts. They have a network address and a host address. And you may hear me refer to this as the device address. Okay, so there are blocks of addresses that are reserved. So there are, for example, what we call blocks of space designed for local or private internets. So these would be like the networks that you would have in your home. And we have 10.0.0.0 to 10.25.25.25. We have 172.16.0.0 through to 172.31.255.255. And this is the range that you're likely to have, for example, on a local area network. You'll see these used often by ISPs, etc. And this is local area network essentially, which we will abbreviate as a LAN. DNS, so I will put in brackets up here. DNS. And DNS is actually the most widely used application on the internet. And what DNS does is it maps a computer address to a domain name. In other words, if you type in www.abc.com, that actual site, abc.com, has an internet address or an IP address. The IP address is mapped to the name abc.com using DNS. So the purpose of DNS is to map devices on the internet to their domain, to their actual domain names. So thing that goes on here is that humans generally are not very good at remembering numbers. So we map the numbers to domain names using the domain name service. Okay, so whenever you use your computer to access a website, so you're sitting at your computer, and you type in www.abc.com. Your computer reaches out to a DNS server, and the DNS server returns the IP address. Okay, so you can think about DNS as being a global, and it is global, and is a database that maps domain names to IPs. So an example, tcpdump.org will have an IP address that's associated with it. And this is all managed, so domain names are managed by ICANN. And ICANN is the Internet Corporation for assigned names and numbers. And there are multiple accredited registrars. So a commonly used one is Domain People. So if you wanted to, for example, register a domain name, you can go to Domain People. They will register the domain name for you. And then you actually enter the IP address where the server is located into Domain People's website, and that will map your server to the domain name. And then anytime somebody types in the name of the domain name, the DNS system will return the IP address of your server, and then your computer can actually access that because it now has the address. So DNS could be thought of sort of like a big phone book. Okay. Each domain is administered by the owner. So it is up to the domain owner to be responsible for keeping the addresses up to date. Now, from a forensics point of view, this could raise some problems because this is where we get the, obviously, we get the opportunity for misdirection and so on. In other words, a IP address could, or a domain name could come back to an IP address that redirects to another IP address, this type of thing. And so we want to take that into account. Plus, it is possible to have a local domain name server. So the DNS software that runs the DNS servers is downloadable off the internet. And anybody can set up a DNS server for a local company. So one of the other important things is that, and that is that most name servers are capable of doing reverse lookups. And that is where you can take an IP address and map that back to the domain name. So in this case, you type in the address and the system will return you the domain that belongs to that IP address. So you can use a command line tool called NSLOOKUP, and that will give you the IP addresses and the domain names. So it's a name server lookup tool. NSLOOKUP can also do reverse lookups. There's multiple utilities that run under DOS, and there are also multiple utilities that run on Windows. And these days, of course, there are utilities that actually run off of websites. So all you have to do is go to the website, and the website will actually map you the IP address to a domain name, or the domain name to an IP address. Okay, Dig is not so commonly used anymore, but the domain information groper has been a traditional tool for querying DNS servers. Dig, for example, would allow you to download all of the IPs and domain names that are associated with a a particular domain. So if we had, for example, ubc.ca, we could use dig to query ubc.ca and get the IP address of every computer or every host that is on UBC's network. So to find information about domains and IP addresses, I'm providing you here with a list of URLs. And just as they say, so you can get North American addresses from Aaron. You can get the European ones from ripe.net. APAC, US military, .gov. Okay, all .gov addresses belong to the United States government. And for Whois searches, you can do that off of Network Solutions. So you can obtain an awful lot of information from those particular servers. Now the thing that you have to realize is that the information on the servers is provided by the person who does the registration, so it does not have to be accurate, and that information is never verified for accuracy. Now I will give you a caveat, and that is that, at least in Canada, domain registrars will actually send out a little questionnaire once a year to verify that the owner of, for example, a .ca address actually resides in Canada. However, if somebody wants to be misleading, it's entirely possible to register an address, use false contact information, false phone numbers, false addresses, and it is absolutely easy and simple for somebody with nefarious purposes to get away with that. Traceroute is another tool that can be used, for example, to trace IP addresses. There is a traceroute tool on the internet that you can actually access off of a website. So to do that is fairly simple. If you just simply Google on traceroute or a traceroute website, and what will happen is if you type in the name of, or an address name, or a URL, the system will show you all the computers or all the routers that your packets pass through between your computer and the computer that you're accessing. That's very handy from a forensics point of view. The reason being that we can use that to find the route packets have taken. And while there is no hard, fast rule that says packets have to take the same route every time, they will tend to. So this may provide us with a certain amount of information. You're able to list what we call the hops, or every server or every appliance through which your packets pass on their way to another computer. So a few URLs here again for traceroute servers. And again, you can simply use these servers to get a picture of what route your packets are taking. It's also a program that you can download, and that's VisualRoute. It is a free download, and it will allow you to trace the packets directly off of your computer. So how does traceroute work? essentially it sends packets to the computer that you're tracing to. So it will essentially, what happens is it will send out a packet with what we call time to live of 1. That means that packet will make it to the first hop and it will die. And because that happens, that device will send back what we call an ICMP echo. That can be used to map, as we do this one at a time to live of 1, time to live of 2, time to live of 3, and so on. We can map all the way to the destination host because the packets will die at each server or each hop on their way to the destination. They'll return what's called an echo, and the echo can be used to actually map the path of the packets. Okay, handy use for this is to confirm or deny contact information from the DNS database. Okay, so we talked earlier on about TCP and UDP ports. You can get more information at ISS.net. Also exploits, ports, and so on. So more than one application will run on a single computer with a single IP address. Now, what that means is that we have ports. So we have ports and port numbers. Range from port 1 all the way to port 1024. So examples, port 80 is the HTTP port. Okay, so a lot of ISPs, so these are generally ISPs, and normally these will be regular consumer internet. So what this means when we talk about a dynamic IP is that the IP address changes or can change every time that computer connects to the internet. This makes it difficult to run a server. It makes it possible for somebody to set up a server on a temporary basis. There is a service, or actually several services, that will map a dynamic IP address to a fixed IP address. In other words, the actual IP address of the server could change over and over and over again, and these services provide what we call a static IP address to a dynamic IP address. So let's say you were a bad guy and you were continually moving your server. So if you were serving out, for example, some type of bad pornography, or if you were serving out some type of illegal content, you might want to keep moving your computer. You might want to keep using different IP addresses in different locations. However, you want your user base to be able to find or to be able to use your service. So one of these types of services that provide a static IP and map it to your dynamic IP will provide you with that. You can keep moving around and thus try and avoid detection. At the same time, every time your devices or your servers are running, your user base will actually be able to contact you using a dynamic or a dynamic DNS service. Okay, so there are attacks that can be executed against TCP/IP. So the thing to remember is that TCP/IP were never designed to be secure. The services that run are inherently insecure because they're running on an insecure platform. So, to give you an example, we want to talk about something called a three-way handshake, which is used to establish a TCP connection. So if I move forward here, we look at the case where Alice wants to connect with Bob using a TCP connection. So first of all, Alice sends a request packet to Bob. So it will have a sequence number. SYN, by the way, stands for synchronize. So this will have a sequence number X, whatever that happens to be. So that first packet to Bob will be assigned this sequence number. Bob will send a packet with sequence number Y. So this might be 100, this might be, okay, so this could be 100 or whatever on the X. Y will return a totally different number. And it will have an acknowledgement. And that acknowledgement will be X plus 1. So if, for example, X, X equals 1024, then X plus 1 would be 1025, and so on. Alice sends back a finish packet with Y plus 1. So Bob has sent Y to Alice. Alice responds with Y plus 1. So if this was 100, then Y plus 1 equals 101. Now in reality, the numbers are going to be bigger than this. This is highly simplified. This is a control bit. So the packet headers, or the headers that are used in actually creating, I should say, the headers that are used to direct packets are included with packets. So a packet on the internet looks like this. So this is our packet. A part of this is going to be header, and a part of this is going to be data. Now the header contains what we call metadata about the packet. Okay, and these bits, for example, ACK and fin, are simply bits. So we would have control bits, and depending which one is a 0 or which one is a 1 will determine these. So each bit place, and bits are numbered. So if I look at these bits here, they are numbered from right to left. Total of 8 bits. And each one has a purpose. So bit 1 would be one of these control signals. If it's a 1, then it would represent one of these control signals. It might be an ACK, or it might be a fin. There are synchronized. There is a number of these control features built into the protocol. So IP spoofing. What happens if Carol wants to impersonate Alice and establish a connection with Bob? So let's say that Bob and Carol are married, and Bob and Alice are having an affair. Carol finds out about the affair, and she wants to connect with Bob and pretend she's Alice. In order to do that, Carol has to complete the 3-way handset. How does she do that? She can claim Alice's IP address in her first packet. Bob will send the second message type Alice's IP. Alice may ignore this because she never started it. She might just think this is an erroneous packet. And so she returns an error message to Bob. The only way that Carol can actually successfully do this is if she can stop Alice from responding to Bob. Now there are ways of doing this. Most commonly, this is achieved using a denial of service attack. In other words, what Carol could do is flood Alice's computer with packets using a third party or a fourth party server or a computer. Okay. The other thing she can do is she can send an ACK back to Bob, y plus 1, but she has to know the value of y. In order to do this, it is essential that Carol gets the value of y. Now, here's the thing. This is largely an academic concept. This idea of being able to spoof an IP address and generate this kind of a false connection. So the thing to walk away from is this is highly theoretical. And it is based on a hole or a vulnerability found in the TCP protocol, and that was done by a fellow named Robert Morris. The problem is, you remember the sequence numbers? It's y plus 1, then y plus 2, then y plus 3, y plus 4, and so on. So this is the problem. This sequence, or I should say this pattern, makes the sequence predictable. So you can read a paper on this. There is an IP address, or pardon me, a URL, and you can read a paper on this problem. The idea is to come up with and to devise protocols that make the sequence numbers unpredictable. If the sequence numbers can't be predicted, this type of an attack doesn't work. Okay, so the way that this is actually accomplished is to use relatively strong, or to use random generators to generate the value of y. In other words, y can't start at 1, or start at 100, or 101, or 1024, or whatever. Instead, the initial value of y must be random. And this means that it's impossible to predict sequence numbers. This is important, and the reason it's important is that TCP plays a very central role in networks. So for a digital investigator to understand exploits, it's really imperative that a digital investigator understands the TCP/IP protocol and the TCP/IP suite of protocols. Now, as an analyst, what's really important? What's really important is that you're able to converse somewhat coherently with the actual person doing the forensic investigation. Now, generally, that is somewhat important. And obviously, in order to do a correct analysis on the technical evidence that's presented to you, you need to be able to understand this in depth. Now, understanding TCP/IP protocol and network protocols and the whole information area of network communications is a series of courses all unto themselves. So you could take a series of, for example, what we call Cisco courses. BCIT runs very good Cisco courses, and that will give you a lot more information about how network traffic works. Remember here, we're just doing an overview. We're just talking in very, very overview, top-down sort of terms. I want to talk to you folks about Tor. And Tor is the onion router. Okay, and Tor is used to provide anonymous, oops, I can't spell anonymous anymore. Communications. So let's take a look. How Tor works. So essentially, let's say that Alice wants to communicate with Bob. So we have Alice, and we have Bob. Now, if Alice connects directly with Bob, then the route the packets take is predictable. And anybody, in other words, any computer sitting anywhere on the route that those packets take is able to read the packets. Now, even if an eavesdropper was able to read the packets, that is one issue. Now, the packets could be encrypted. So the packets encrypted, or the packets being encrypted, only means that the data is encrypted, not the packets themselves and not the packet header information. So there is an attack that's possible, and that is what we call a traffic analysis attack, where the packets are observed, or the frequency of packets is observed to determine the source and destination of those packets. If the data is not encrypted, then an eavesdropper is capable of not only getting the source and destination of the packets, but also capable of monitoring the entire communications. So the way that people will try and circumvent that is they will use something called Tor. Now on Tor, first of all, the packets themselves can be encrypted. So they are encrypted within the Tor network, but they don't necessarily have to be encrypted between the Tor network and, for example, the originating host and the destination server. Most bad guys will encrypt their packets. So that means they are encrypted from step one all the way to the end. So what happens? Step one is that Alice is going to get a list of Tor nodes from a directory server. So this directory server we will call Dave. Okay, so once she gets a list of nodes, she's capable of connecting to one of those nodes. So Alice's Tor client picks a random path to the destination server. And these are these green links here. Now, any red link is in the clear. In other words, this red link is an unencrypted. This is a weak spot. And the reason it's weak is that any computer that's monitoring here can read the packets because they're not encrypted. The data is not encrypted. However, Alice has been smart. She's encrypted her information. And then inside this Tor network, which is really a bunch of computers spread all over the planet, anybody can download the Tor software. Essentially just Google on the Onion Router project, and you can download this software. You can become a Tor node, and then these packets will pass through that computer. Or you can use, or if it's the Tor browser, that computer is capable of using the Tor network. So if later on Alice comes back, her computer is going to choose a different entry route. So every time you connect to the Tor network, it has a different entry node. The packets are bounced back and forth. Between these computers. So there's different random links that are formed inside this network. And this is what allows the users to maintain anonymity. Now, worth remembering that the Tor network was developed by the United States Navy, and that this technology was designed so that agents in various parts of the world could actually communicate in an anonymous manner. So the question is, what kind of bad things does Tor allow criminals to do? So bottom line is, criminals can do bad things anyways. So the bad folks already have the tools and multiple ways and multiple options that provide better privacy than Tor does. There are multiple hacks and multiple exploits of the Tor network. For example, if, say, a government actor were to own enough Tor nodes, they would be able to essentially predict the path of packets through the Tor network and so on. So Tor provides reasonable anonymity, but it's not a guaranteed or a complete anonymity. So bad folks can use what we call burner phones, so they can use cell phones, throw them away when they're done. They could break into computers in another part of the world and use those computers as proxies to launch attacks, using spyware, viruses, and any of a plethora of other techniques that would allow them to take control of other computers. Now, what you need to understand is that we talk about Windows here because Windows is essentially the most insecure of all operating systems available in our world today. and by far 99% of all attacks are launched against Windows because it is inherently very insecure. Okay, so there's a lot of things you cannot send over Tor. You can't launch, it won't work for things like SYN flooding. Tor does not work, for example, for streaming video, audio. It doesn't allow Telnet or SSH connections. So there are a number of protocols that won't work very well over Tor, which makes it relatively impractical for people to use it to do bad things. Tor does not allow spamming. It is built into the Tor protocol. So sending spam email doesn't really work very well. It is possible if you own an exit mode or an exit node to enable port 25 on that node. On the other hand, Tor does not lend itself well for spamming because Tor networks, as a general rule, refuse just to deliver the mail in that way. So again, you can go to the Onion router, just Google on the Onion router or the Onion browser and go to the Tor website and you can research Tor. Tor has a somewhat checkered name in the world because there are potential abuses. On the other hand, the protocol was not designed to be abused, and it was designed in such a way as to try and hinder the abuse by criminal elements. So there are issues. Tor can be used to connect to proxies. There are lots of vulnerabilities in Tor. It is possible to use Tor, for example, to control a botnet or to communicate secretly with other armies, spies, cyber espionage, all those types of things. The other thing that should be mentioned is that people who try to use Tor, for example, to send abusive emails, often forget the fact that the browsers will generally give away the IP address of the originating host. So Tor does not necessarily lend itself very well to that, although it can be used obviously for spam emails. Okay, that's it for now. Bye.